In this session, I'm going to teach you on k-nearest neighbors briefly. So what is KNN? So KNN is a non-parametric instance-based algorithm used in supervised learning setting. Okay. So here in k-nearest neighbors, what does k stand for? So k is a hyperparameter which is chosen arbitrarily by the user and will determine how many nearest neighbors does the algorithm look for a certain point A. For instance, if k is equal to 3, the algorithm will look for nearest 3 points around an unlabeled point A to determine the label for the point. It's nothing but you have an unknown point and you have to pass the number of nearest neighbors you want to find. So when you give k is equal to 3, it will find the three neighbors and the majority of the classes which belongs to a particular class will be considered as the class of the unknown point. So how does the algorithm determine the distance between the points? The most common distance measurement is done using Euclidean distance. We have already seen that in the previous lectures of k-nearest neighbors. Essentially, it's nothing but a Pythagoras theorem. So it is a hypotenuse. Okay. So how the objective here is to implement a k nearest neighbor. So what are the steps we are going to follow here? Here, first we'll read in the data set and understand the features. Okay. So let's do that. So for that, so let me complete the steps in all. Next, separate data sets into training and testing set. Then training and train the model using the training data set and do the evaluation using the testing data set. So determine how well the model performs for different values of k and on the testing data set as well. So do the visualization of the models evaluation, how it performs for different values of k by plotting it. Okay. So first, read the data set in the package. Okay. First, let's import the basic packages. So let's import the libraries. So let's NumPy, import NumPy as NP, import pandas as PD, import matplotlib.pyplot as pyplot as plt, import cbon as sms. Okay, so also, so we have iris data set over here. You can see here. So we have our iris data set over here. So these are the independent column that we have, and this one species is the dependent column. So, so now let's load data set from sklearn. Okay. So let's call the iris is equal to pd dot read csv read underscore csv of iris dot csv. Okay, let's run this code now. Okay, no problem. Now what we'll do is that, so next is what are the set of questions that we can ask from the data? What is the number of rows and columns in the data set, right? So for that, let's see number of rows and column iris.shp. So these are the number of rows in our data set and these are the number of columns that we have. And next is, so describe, we will describe iris.describe. So this describe function will give, so what we can make is that here we can make our index column to be 0, index call is equal to 0. Okay, let's run this code. So we have 5. So now let's do the describe. So we have our independent columns from our data set. So if you want to see the iris data set, I will show you that iris.head Okay, this is the iris.head data set we have. So once you perform the describe function, this will give you a 5 point summary as well as mean and standard deviation for the numerical data only. Since species is not a numerical data, it is categorical variable, so we won't be getting the 5 point summary for that. Next, what can we do is, so now let's implement a KNN algorithm. So instead of writing this over here, so let me write over here for this. We delete this. Okay. Okay, now it's fine. So now implementing KNN algorithm. So we need to split the data set into training and testing set by random sampling. Okay. Use the testing set to validate our model. We have to use our testing set to check how the model performs for our unknown data. Okay. Why is it important? Given whatever data we have, we don't have target function to generate more correct answer to see if our model works. So we have to hide some data from the algorithm and use it to test our model. So we have to make sure that our model has some unseen data so that we can check the predictions of the model for our unseen data and compare it with the result so that we can classify if it's a good model or bad model based on the testing accuracy. Okay. So now what we have to do is that from sklearn, so let's split the data from sklearn dot model selection import train test split. Okay. So let's call, so we also need a label encoder, right? Since our data here, the species is the categorical variable, we have to convert it into a numerical one. So for that, we import from sklearn dot deep processing, we import label encoder. So a label encoder is a pre-processing technique. Use it for converting a categorical variable into a numerical variable in our columns. So whatever column we have, like species column we have, will map those classes into 0, 1, and 2. So that will be done by label encoder inside label encoder only. So first we have to instantiate label encoder. So LD is equal to label encoder. So now, so what we'll do is that let's take X. Okay, X is our independent variables in our data set. So the independent data variables in the data set is from sepal length till petal width. So first we'll take, so from a data set is iris of all the rows and everything dot ilog we have to go dot iloc all the rows and till the last column we want data and we want these values. Since we want it in the form of arrays, selecting all columns except the species column over here. And now what we can do is that we have to uh, take y names, right? So y names will be, so x is done. So y is equal, y names is, so we want iris of species. Species is our dependent variable dot values. So we'll take that. Now what you have to do is that, so y is equal to, so you have your a label encoder, you have to transform it. So dot fit transform. Since you have to transform it into a numerical one, so LA dot fit transform of you pass y names. Okay. Now let's print I and check how it is performing. So invalid syntax it is saying. So we want it from Okay, here you have to pass. We want all the rows and we want only particular column. So we have our data set. We have three types of species. You can see the mm, values over here. Iris dot species dot unique. So we have unique. So let's pass this. So we have Setosa versicolor and Virginia as our unique values. So it is assigned with 0, 1, and 2 respectively. Okay. So let's get back our head. Okay. So now it's fine. So let's see by splitting the data set into 50% training and 50% testing. So now we have X train, X test, Y train, Y test is equal to train test split of, we have to pass X over here, X comma Y comma test size we need to pass. Let me pass test size as 40%. Okay, 40. Let me pass it as 50% for, since I have already taken. Let's splitting the data set into 50% training and 50% testing. Now let me run this code. And now next what you can do is that let's print the shape. Print X train. X train. Sorry, this is capital X. X train dot shape. Okay. Let's print X test dot shape. So we have our 50% for training and testing. So now what we can do is that, so now we can import our model from sklearn dot neighbors, import k neighbors classifier. So let me run this code. Okay. So no problem. So now what we can do is that, so let me instantiate k neighbors classifier into KNN, k neighbors classifier. So let me pass number of neighbors here as of 3. Okay. Let me pass number of neighbors as 3 for for example. Okay. Now we have three classes, which is an odd number. Okay, so we have three classes 0, 1, and 2. Hence, to avoid instances of ties in majority voting, we will avoid using even numbers to get a k is equal to 2, 4, 6. In short, avoid using even numbers. That's it. Okay. Now, what we can do is that, so let's train our model KNN dot fit of X train, comma Y train, and let's do the predict KNN dot predict of X test. So this is model is created based on training data over here, and here prediction is done over here in KNN dot predict. So we have our prediction over here. So now what we will do is, now we will do the evaluation. For evaluation, we use confusion matrix. So from sklearn dot metrics, import confusion matrix. So now we will pass confusion matrix of, so we'll pass, what we will pass is, we have to assign this to a variable. Sorry for that. So y predicts, predicted, prediction, I will give you a prediction is equal to KNN dot predict. So we have our values over here. So confusion matrix of y test, comma, y prediction. So let me run this code. So more module dot sklearn is on. So you could see that we have is 27, 26, and 19 as our values. That is true, true positive, true negative, like that kind of value for since we have three classes. So you can say that 27 of the classes are correctly specified, and 26 of the one classes are class belongs to one is correctly specified, or 19 of the classes belong third class, second class is correctly specified. Or you can say that the unique value setters and other two values are specified correctly in the range in 27, 26, and 19 correctly, and these three values have been equivalently classified. Okay. So now let's see the accuracy score. So from sklearn dot metrics import accuracy score. Okay. So evaluate the accuracy of the output of the model against y values of the test set. Okay. So let me do that. So let me call it as score. Score is equal to accuracy score of. So we want to pass y test comma y prediction. Accuracy to score of y test comma y prediction. And we pass another third variable if we have, which is, let me run this code first, and let me print score. Okay, accuracy score we get from here. Accuracy score, we have to run this code. So we have a accuracy score of 96%. Okay, 96% of the data is correctly classified. So what we can do now is that since we have passed a k value as 3 for number of neighbors, now we will check for other values of k. So how to choose k is a hyperparameter which is often chosen by tuning process. Have a list of candidate hyperparameter values. Okay. Let's take k value from here. So first is have a list of candidate hyperparameter values. So k range I will pass over here. K range is from a range of 1 comma let me say 40 or 30, whatever you want. Let me say 40. Now let me have scores. Okay, what are the scores for each of the k value? Let me say. So for k in range of k in k range, so we have already assigned k range, right? So for k in k range, KNN is our list instantiate our k neighbors classifier. K neighbors classifier of, so let me pass number of neighbors as, and number of neighbors I will pass it as k. Okay. Now let's do the training of model. KNN dot fit of x train comma y train. Now we'll do the prediction. KNN dot predict of x test. So I will pass it into a predict variable by predict equal to KNN dot predict of x test. So so we have our list, right? So let's append the accuracy scores. Scores dot append of accuracy score of y test comma y prediction. Okay. It's too much. Let me take it as 30, k value is 30. So now let's run the code. Everything is perfect. It will run. Okay, no problem with the code. So now let's do the now let's print the scores value. Okay, over here itself scores is equal to scores. Let's be print. Okay, these are the scores we have. So you don't want this. So now we'll do the plotting, okay? We'll do the plotting against the for each value of k. So for range of k, okay, so for X range from 1 to 30, what are the scores we get? Okay, and where we get the maximum score? At what value of K we get the highest score? Let's check that. So first, what you can do is that so PLT dot plot of so K range is our X variable, and we have our scores as a Y variable. Okay, and now PLT dot X label we pass X label, right? X label of, so what is the X label? We can say value of K for KNN. Value of K for KNN. PLT dot Y label is testing accuracy. So now let's run this code and check. So okay, we are getting this kind of code. So here at k is equal to this value, we are getting maximum. Okay. The value is around 6, it is around here. So it is almost 7. At value where k is 7, we are getting maximum accuracy at this point. So we observe that the simple KNN algorithm training on 75 rows of data with n is equal to 5. Actually, here it should be not n is equal to 5. This is around n is equal to 7, right? Let me check over here as well. So, scores. So, this around n is equal to 7, I guess. 1, 2, 3, 4, 5, 6, 7. Okay, so at n is equal to 7, we are getting a maximum accuracy of 97.33%. So, we are considering n is equal to 7 was able to achieve 97% of accuracy, 97.3% of accuracy in the prediction of the remaining 75 rows of unseen data. However, with the small size of data, model generalization is still an issue, and accuracy level might vary with another random sample of data. Okay? What are the drawbacks of KNN model we can see is too many dimensions will make distance calculation very complicated. Yes, too many dimensions in the sense the larger the number of features, there is a chances that data points calculation, distance calculation is complicated and data points become further away from each other, thus not effective neighbors. You might have realized that the scale of each feature must be the same. Yeah, in k-neighbors, nearest neighbors, we have already seen that all the values should be on the same scale. So if you see here, we had not done the scaling here, but there can be for various different types of data where we have different scaling. Here it's not that varying, so but you have to do the scaling so that all the values, all the features have the same scale. Okay, each feature must be in the same scale. If not, feature that is numerically smaller than other features will always be more significant. Okay, not very model based. Hence, you can't quite explain the results of the model after you use. So I hope that you enjoyed this session and you understood this session. So I will be covering naive Bayes theorem in the next class. Thank you so much for attending the session.